Alright, let's talk about ionic compounds in aqueous solutions. First of all, we need to know what an aqueous solution is. So our working definition, we're going to say an aqueous solution is a solution where waters are solvent. So water is the solvent. Remember, solvent is what does the dissolving. The solute is what is dissolved. So in our situation, our solute is going to be whatever ionic compound we're dissolving into water. Okay, and our first compound dissolving into water, our first solute, let's just use sodium chloride for ease of an example. Couple things you need to remember about water is water is a polar molecule. So we're going to kind of draw Mickey Mouse here with the polarity labeled, positive ears, negative mouth, and that's our polar water molecule. Remember, that means that it has a partial positive charge on one end and a partial negative charge on the other end. Now to our solute, to our sodium chloride. It is an ionic compound, which means it is made up of ions, the sodium ion and the chloride ion. Also, some more things for you to remember is that opposites attract. Okay, so when this does dissolve in water, the negative end of the water molecule is going to be attracted to the positive end of the sodium chloride. The positive end of the water molecule is going to be attracted to the negative end of the sodium chloride. Okay, we have a very crude drawing of the ionic compound sodium chloride. The positives, again, are sodium ions. The negatives are chloride ions. So a crude, like, crystal structure. Pretend you can see it in 3D. And water is going to attack this crystal structure. And dissolving really is like an attack. Those water molecules are going after and ripping apart this ionic compound and this crystal structure we have here. And this is sort of what happens. Here's a zoomed in view of what happens if it gets a hold of a chloride ion. So that's one of our negatives from over here. Water gets a hold of it. I don't really want that arrow there. Bye-bye. And this is what happens. Our positive hydrogen end surrounds the chloride ion. Okay, and it just rips it off. So then, what this really is not just a chloride ion, but it's an aqueous chloride ion. It's chloride ion in solution. So the water molecules are surrounding the chloride ion. The same thing would happen to the sodium ion, but instead of hydrogen, it would be the oxide molecules, or the oxide end surrounding it. And here's our example of a sodium ion being surrounded by water and ripped off from its ionic lattice. So that's what happens when things dissolve into solution. One more thing on this topic, two terms that you need to be aware of. We have something called a strong electrolyte. These are ionized 100%. In water. Another word we use is disassociated. Which means they're pulled apart into their ions completely. So all of the crystal structure is pulled apart when it dissolves in water. Our strong electrolytes are our ionic compounds. We also have weak electrolytes. They get ionized, but not 100%. And then we have non-electrolytes, where they actually stay together. These are molecular compounds. So when sugar dissolves in water, it stays as a sugar molecule. It's not ripped apart into carbon, hydrogen, and oxygen. So these are molecular compounds. So water just surrounds the whole compound instead of pulling the compound apart like it does in ionic compounds. Again, weak electrolytes are only partially ionized, not 100%. So those are our last few terms for dissolving compounds in aqueous solutions.